Welcome back to Stacks class. In our last lesson, we introduced the concept of confidence intervals as a way to estimate an unknown population parameter, and we talked mostly about means and a little bit about proportions. We'll talk more about proportions in this lesson. We learned that a confidence interval gives us a range of values for a parameter based on our sample data, and it provides a level of confidence in our estimate. So now we're going to build on that foundation. We're going to move from thinking about or talking about the concept of confidence intervals to actually calculating them. We're going to learn how to determine the margin of error, how to construct different types of confidence intervals, such as z-interval. We're going to talk about a t-interval, and then we're also going to talk about the z-interval for proportions. So we're going to quickly review. We have a confidence interval is a range of values that is likely to contain the true value of a population parameter. It has three main parts. Here are the main parts. We have the point estimate. That is the sample statistic. That is either the sample proportion or the sample mean, and that's what's going to be in the center of our interval. The margin of error gives us the range above and below the point estimate. So that's what's going to create the range of values to give us our upper and lower bound to create the interval. So we would take the point estimate and we would add the margin of error. That would give us our upper bound, and then we would take the point estimate and subtract the error, and that would give us our lower bound. Then we also have the confidence level. And the confidence level dictates how wide the interval is. So the higher the confidence level, the wider the interval, which means it's more probable that that population parameter will fall on that interval. So here's our sketch. Here's our population parameter. In this case, we're looking at the mean. So my upper bound is the mean plus the error, and my lower bound is the mean minus the error. And you can see that the interval contains approximately 95% of the data. Now let's take a look at the different types of confidence intervals we're going to talk about. This table will help us figure out when we need to use which interval. So this first interval is called a z-interval. And this is when you're trying to estimate a mean. For the next interval, this is called a t-interval. And for this interval, we're going to use a different distribution. We're going to use what's called the student t distribution. And I'm going to discuss what that looks like here in just a minute. So when you want to estimate a mean, a t-interval is another way that you can go. And then the last one is called a z-interval for proportions. Now, this is when we use the normal distribution to approximate the binomial distribution. So we're going to be using the central limit theorem there. And this is when we want to estimate a population proportion. Now, let's take a look at the requirements. So a z-interval is used when the population standard deviation is known. So that's if you know the population standard deviation. Don't forget there's two kinds of standard deviations. We have the standard deviation that comes from the entire population and the standard deviation that comes from the sample. In real life, it's very rare that we know what the population parameter is. So in real life, you're probably not going to use z-intervals very much. So in order to use a z-interval, though, you also have to have these other requirements. The population must be normal, or the sample size must be greater than or equal to 0. The samples must be picked randomly, and the samples must be independent. Now, the big difference between the z and the t, because these are both intervals that we use to estimate a mean, but the big difference between these is that we use a z interval when we know the population standard deviation, and we use a t interval when we don't know the population standard deviation. And typically, not all the time, but typically we use this for when the sample sizes are small. And then let's see, for the z proportion interval, we're going to use that when the sample size is big enough. And in order for the sample size to be big enough, these conditions must be met. You need to be able to take the sample size times the probability of success and get a number greater than or equal to 5. And you also need to be able to take the sample size times the probability of failure, that's your Q, and make sure that that's greater than or equal to 5. So that's making sure that the sample size is big enough. And then you also have to make sure that the samples are random, they're independent, and the sample size for each sample needs to be the same, and the probability of success for each trial needs to be the same. So these are the conditions. As we start going through the examples, we're going to apply and use this table to help us figure out which interval to use. Now, here's how we would calculate the confidence intervals by hand. This part that I'm highlighting in each of these statements, this is the error that you use to add and subtract to your point estimate. For a z interval, since we're trying to estimate a mean, we would use x bar, and then we would add and subtract the error. Here's the error. It's all of these highlighted expressions in this pink. For a t interval, you would do the same, because for a t interval, you're estimating a mean. And so you would take your point estimate and you would add and subtract to your error. And then lastly, we have, if you're estimating a proportion, you would take your sample proportion, which is your p hat, and add it and subtract it to your error. All right, let's put these formulas into practice. I'm going to show you how to do this by hand, and then I'm going to show you how you can use GeoGebra. So in this question, it says a researcher measures the heights of 36 male adults and finds the sample mean to be 69.2 inches. The population standard deviation is known to be 3.1 inches. Construct a 99% confidence interval for the population mean. Okay, so let's write down all the information that we have. We are first given, when we read through this again, we have 36 adults. So we have that n is equal to 36. We have that the sample mean is 69.2. So I'm going to put down that our point estimate, our x bar, is 69.2. We're also given the population standard deviation is 3.1. And lastly, we're told to construct a 99% confidence interval. So I'm going to say the confidence level is 0.99. Now we're asked to construct a 99% confidence level for the population mean. So this is going to be an estimation for a mean, which means we're going to either use z interval or t interval. The major difference, if we go back up to the table, the major difference that we talked about between these two is that you know the population standard deviation or you don't know the population standard deviation. That is the major difference between the two. So, because in this case, we do know what the population standard deviation is, we're going to use a z interval. To find a z-interval, our formula is to take our point estimate, and then we're going to add and subtract the error. And the formula for the error, if you look up at the table, is z critical times the population standard deviation divided by the square root of n. We're going to have x bar plus or minus. Our z critical in this case is 2.58. Pause the video and go into GeoGebra and make sure that you remember how to find the z critical. If you cannot remember how to do that, go back and look at the previous lesson because I have examples in there for that. So we're going to take 2.58 and we're going to multiply it by the standard deviation, which is 3.1, and then divide by the square root of 36. Let me finish up here. That gives us x bar plus or minus. Now our error, when we calculate our error, we're going to get 1.3308. So that 1.3308, that is coming from this calculation right here. All I did was work that out and then I carried it up here. Our point estimate is 69.2. I'm going to take the 69.2 and subtract the error, which is 1.3308, and I'm going to get 67.8692. For the upper bound, we're going to take our point estimate, which is 69.2, and I'm going to add the error, which is 1.3308, and I'm going to get 70.5308. Okay, so our confidence interval, if we write it in interval notation and we round it, let's say we round it to two places, we have 67.87, comma, that's our lower bound rounded, and then 70.53. So there's our confidence interval. Now, for our interpretation, we would say we are 99% confident that the true population mean falls between 67.87 inches and 70.53 inches. So these are in inches. We want to make sure we keep track of our units. Now let's hop over to GeoGebra and I'm going to show you how you can check all of that on there. So when you're in GeoGebra and you're looking at your probability calculator, up at the top here you'll see distribution and you'll see another tab called statistics. You want to click on that statistics tab. And the very first thing at the top, you're going to see a drop-down menu to choose from. Now, we are doing confidence intervals, which means we are estimating a mean or a proportion. In the example we just did, we used a z-interval to estimate a mean. So up here where you see all the tests, we haven't covered that yet. These are for hypothesis testing. So for confidence intervals, you want to look down here where it says estimate. And we used a z-estimate of a mean. So we're going to choose that one. We're going to put in the confidence level here. So I'm going to change that to 0.99. That was our confidence level. Our sample mean, which was our point estimate, was 69.2. Our standard deviation for the population was given, and that was 3.1. So I'm going to enter that. Our sample size was 36. Now, if you look down here at the bottom, it says z-estimate for a mean. It gives us the information that we provided here. This SE That is the standard deviation for the sampling distribution. So that's when we would take the 3.1 and we divide by the square root of 36. That's where this is coming from. N is our sample size. And then if you look at where it says lower limit, that's what we got when we did it by hand. Our lower limit of the interval was 67 point, I think we said 87 when we rounded to two places. And then our upper limit was 70.5308, and we got 70.53 when we rounded. And this is how we're stating our interval, right? It's the point estimate, 69.2, and then we add and subtract to get our upper and lower bounds. And there's the error that we got, 1.3308. That was the error that we calculated that we added and subtracted from the 69.2. So this is how you can use GeoGebra to calculate your confidence interval. Or if you want to do it by hand, you can use this to check your work as well.